But this one's all about reactions. So there's 4 different types. There's substitution, addition, condensation, and elimination. And then we're going to talk about polymers, which I have a Doritos bag for that reason. We'll see why. So first off, the substitution reaction is one where, just like if you ever learned genetic mutations, same idea where one atom replaces another atom or a group of atoms. So you might have a reaction between a methane, which is an alkane, and a chlorine, which is a halogen, to form an alkyl halide. You can see here we have CH4. That H is then replaced with a Cl, and we have chloromethane instead of methane. So it's an alkyl halide because it has both of those components. So that would be an example of a substitution. An addition would be where 2 parts of a molecule are added. So for example, hydrogenation is where 2 hydrogen atoms are added to an unsaturated molecule. So vegetable oils, those are long chains of carbon atoms with lots and lots of double bonds. Slide's not working here. So it looks something like that. And you can add H2, and then it essentially becomes part of that chain. So that would be like an addition reaction. Condensation reaction. So that's where 2 molecules or parts of the same molecule combine. So I have 2 smaller molecules there, 2 amino acids shown, and they add together to make a dipeptide. But then a small molecule will be removed. So these 2 will form together, but they have to get rid of their H2O. This one gets rid of an H, this one gets rid of an OH. And then they're condensing to become one, but that H2O is gone. So when this gets repeated many, many times over, you can make a chain of amino acids. And what do a bunch of amino acids together make? You should know this from bio, hopefully. A protein, right? So that's essentially how proteins are formed. And then the last one here is elimination reaction, where basically it's just something is removed. So we have an H and an OH, just take them away, and we end up with water, and it gets replaced by this double bond here. So literally just eliminating part of the molecule. This example exactly is if I heat ethanol in the presence of concentrated sulfuric acid, then this will happen. So let's talk about polymers. Polymers are large molecules that are made up of many small units joined together through organic reactions like the ones we just looked at. They're made up of small units called monomers. So what's nice about polymers is I can either make long chains of a single polymer, or I can sort of add different monomers on and build these different plastics. So in nature, some polymers occur in like starch, cellulose, what plants use to build their the cell wall and things like that. And then proteins are also natural polymers. We can also make polymers, which is what makes them pretty cool. And that's why I have the Doritos bag, because this is actually an example of a synthetic polymer. And I'll show you what happens when we didn't heat this yet. Make a mini bag. So I'll do that real quick. Yeah, here's your little mini Dorito bag. So, yeah, it's just made up of polymers, and then you can see we can shrink them down. Yeah, there's even so that's a polymer that's more flexible, but then some polymers like PVC, they're a lot more durable. PVC wouldn't do this if I put it in the microwave, but polypropylene. There's different synthetic polymers. So molecules of ethene can polymerize with each other and form polyethylene. We just use a catalyst, and we can have a number of polymers chained together, a certain number of monomers long, and this can be repeated hundreds of thousands of times. And we can make really long chains of polymers. So this monomer would be called propylene. Vinyl chloride, which we're hearing that in the news a little bit with that train situation over in East Palestine. But some other like polystyrene. Does anybody know what polystyrene is found in? Yeah, styrofoam, exactly. Or insulation. Piping, that's polyvinyl chloride, PVC. That's what it stands for, PVC. Those are made for pipes. Plastic bottles are made of polypropylene. Latex paints. We did have some back there. I don't know if we have any still, but they can be made up of these monomers, these vinyl acetates, and they just latch onto each other essentially like this. You have a long chain. That's why they're so hard to break down. They're like a double-edged sword. They're good and bad because they can basically be formed however we can make a box, we can make a container, a bottle, we can make shrink wrap, baggies, any like thin plastics, thick plastic. However you want to make that plastic is great, but since it's so hard to break down, we end up with the bad side of it too, with the pollution and everything, since it lasts so long. But a condensation polymer, those condensation reactions we talked about, these are polymers formed by those condensation reactions. They have to contain two functional groups. And I guess that's all I have.